Yeah, my name's Leigh. I'm a DevOps professional. I like to snowboard. I am from Denver. And I thought we'd start off just on a little bit of a lighter note today. This is my dog. He's very cute. And instead of talking about containers, we taught him how to snowboard. He needed a job, and so this is kind of what we spend our time doing. But, if you guys have never had a chance to come out to Denver, we have beautiful weather sometimes. So, yeah. But, yeah, it's my dog. His name's Pepsi. Makes me very happy. Before I get going, I just really want to have reverence for the community. We're all part of a group of people. We're not just obsessed with building systems for the sake of building systems. And so thank yous to people like Bren Briggs, Joe Thompson, the amazing J. Paul Reed. He gave an awesome talk. He's very sciencey and a master's candidate in the area of human factors. Chris Nova and Chris Love from the COPS community, Jerome Petazzoni, Eric Norland, Brian Downs from the Go community. These are all people that have had a very incredible impact on my life, and I know that you guys have lived a similar story. Mentorship comes in many forms, like blog posts and documentation. Without the time and dedication that individuals like these people put into making our community great and fielding questions and helping newbies like a newbie that I was 2 years ago get going, we wouldn't be able to move forward, and we wouldn't be able to care about each other and have the resources that we do today. So get a mentor. Talking about reducing drift, what does that mean? We see the keynotes on stage that are talking about pipelines, moving applications with containers into the cloud, using scheduling managers with distributed systems, and placing our software all over the world in a declarative and manageable way. We're in this green pasture of cloud-native software. You hear about Kubernetes. You're like, oh, use Cloud Foundry. Right? Give your developers a platform. And I promise these platforms are going to be super easy to support. Just start moving stuff out of the old way that you do things into this newfound land of better practice. And then you start to talk to your devs, and you realize that there's a little bit of a dissonance in the way that you do things and they do things. Right? I used to be a Puppet practitioner. We managed a pretty large environment at what used to be DirecTV, and then it was AT&T. And oftentimes, in a more of an iteration-style environment, things are very pristine. They're localized. And you're working in this laboratory-like environment, and then you ship over to the ops teams, and you're like, how am I supposed to support this? I'm supposed to lift this code into a release that's finally orchestrated into complex infrastructure while thousands of people are hitting the application. The expectation is a little bit discomforting. And so this dissonance of iterating on a single machine versus interacting with a data center, that puts us into this awkward scenario, right? How do we scale things? You always hear, there was a tweet going around in Twitterverse, it's like, if you just ask people, how does it scale? You'll sound really smart, right? It's this consideration that needs to go into everything you do. But the reality is, oftentimes people aren't running 5 or 10 application servers on their laptop. But when you go into testing, you start to scale that out, and you see this in our Puppet environments, in our Hyra data, right? That as you start to move into environments, the question of how does it scale is now defined by a declarative and a difference that you can actually point to. And so you might have these strategies that help you work in a smaller environment and move out into a larger one, and this is perfectly acceptable. But what I want to talk today about is maybe questioning if that's a good thing. When we talk about platforms, we always hear these amazing promises. If you can just start to change your workflow to use containers, move towards these immutable artifacts that are wrapping processes in a small unit of thing that can be scheduled out across your environment. If you can just learn how to run a Nomad cluster with secrets management and a software-defined network, if you can just figure out how to run 3 federated Kubernetes clusters and have a very expensive relationship with Dell EMC code where you're using storage drivers and mounting all kinds of persistent data into your clusters, if you can just teach your team how to get into cloud-native promised land, then you'll be able to use these declarative application definitions from your iteration environments and just kind of move them out there, and it'll be super easy. And so you're like, OK, well, I'm at all these conferences and things, and people with really long beards are getting up on stage and saying, hey, this is the right way to do stuff. And then the sales guy from Dell's like, oh, yeah, you should totally use this platform. And so you go back to the office, and you're talking with your boss, and you're like, maybe we should pitch this to leadership. Let's do a Kubernetes lab environment. This is the promised land. And then you start to look into your cloud environments, and you're like, wow, we've got a lot of stuff kind of scattered around everywhere. So maybe let's not do it in the cloud. We don't even know the people who actually own the AWS account. And that maybe might get us into a budgeting issue. We might have to talk to somebody about maybe swiping a different credit card in a different account that's separate from our production environments and stuff. I don't know much about IAM, or I think that this is going to be kind of expensive, and somebody might have a problem with that. You might have a separate conversation like, oh, maybe let's go to our co-location and grab one of the boxes that doesn't run any workloads anymore and stick it into a rack and try to install Kubernetes on it with the newer kernel or whatever. And then you realize that that's going to take work, and you look at your backlog, and you don't have time for that. And you don't know what kinds of conversations you're going to need to have with network engineering in order to actually get that in a place where you can access it on the VPN. And there's just all of this stuff that maybe starts to get a little bit overwhelming, and you feel like this kid. I used to work in an organization of hundreds of thousands of people. And sometimes when you wanted a change to happen and you wanted to experiment, you would run into relationships that you didn't have. Not dependencies on technology, right? But not dependencies on even resources. It's not even always like a money thing. But sometimes you just don't have the best relationship with the networking team or the virtualization team or the storage team. Or maybe you own that, but you don't own this. And suddenly it's placing all of these restrictions on what you can experiment with. You're just trying to do something new. You're just trying to play. You don't even know if it's the answer yet. But you can't move because there's all this red tape. There's all this bureaucracy. And this isn't true for everybody. Some people, I work in a 100-person music company now. It's awesome because I get to own everything. But I mean, is this resonating with you guys? Can I get a show of hands? How many people have struggled to get something that they didn't own before changed? That sucks. And so you start to maybe just not even cut the red tape, you just don't approach it. And you're like, hey, maybe I can just virtualize this on some kind of local environment. Or maybe we buy Bob's Mac Mini, and we can put some servers or run an app server or something on that. But still, this is incredibly limited because virtualization is heavy. Iteration on virtualization is slow. Your laptop typically doesn't have more than 32 gigs of RAM. And that can put some major constraints on your creativity and your ability to experiment with new things. Now, I come from a development background. I used to make software that did operations stuff. I used to make websites that would allow people to make servers by clicking buttons and things like that. We ran a hybrid cloud platform. And when I first found Docker, I became obsessed because as a developer, I'm sure you guys hear this, right? I want my cycle time to be faster. I want my tests to run quicker. I want Jenkins to not be, backed up 30 jobs. And I know we're at the end of the conference, but just to make sure that nobody missed the point, why would you use a container? A container is not a VM. It is primarily, it's using some primitives from the Linux kernel to sandbox a process tree and create some other namespaces. It gets its own little network sandbox, and so it has an IP address. Right? It has a repeatable file system. This is actually a pretty novel part of the container. Right? We were able to layer different ideas and create something that we can create over and over and over again in a very quick manner. But the runtime of that file system is actually isolated. We have novel ways to mount things into different parts of that special file system that's isolated from different environments using volumes, secrets. And when you combine all of these things together, you get an incredibly fast way to iterate on a running process, right? In my new job, I am working in an enterprise Linux environment, and I'd never built an RPM before. That might sound funny to some of you guys. But I was just given this task to patch a really old version of Nginx with some new modules, and the first thing I did was I did a Docker run interactive, and I jumped in a CentOS 6. Instead of making a virtual machine or something, like I was already good to go. I had to pull the image, so that took 30 seconds or something like that on the VPN. And then, like you start to run like a yum update, and you install the epel repository, and then you're like, oh, in order to build an RPM, I'm going to need mock. I think it's what, yum install epel release. Keep in mind, I'm on a Mac just like locally playing in my environment. This is something that's, just casual for me. This is part of my workflow because I have learned how to adopt the abstractions that Docker makes available to me. No, not Docker. I believe now I have the epel repository, so I'm going to go ahead and update that. And I mean, like, there's mock containers out there, right? But I don't want to go look for that, and so I just make sure that I control my environment. And now I can install mock. Sure, right? This is a very casual part of my workflow. This is just what I reach out for when I need an isolated experimentation environment. I don't know how to build an RPM, but I'm going to figure it out. And it's OK if I mess it up, because I can just throw the entire thing away and in 5 seconds have the same environment that I had before. Right? I should have mock now. There you go. Right? If you run mock, it's like, oh, you're running in Docker. Don't run anything else in this container so you don't mess up your environment and that kind of stuff. But no big deal. And so what we see from a container is that we get this really nice way to quickly run a process. And like, that's great and whatever. Software's easy to throw into a box, and containers have radically changed the way that we can not only package but run software. We have all of these networking tricks that we can do, all of these file system tricks that we can create. And it's this really fast isolation. But thought experiment, what if I suggested that everything that you do in your data center is also either run by software in a process or can be emulated by software? So something like a file system, right, that has software that helps run it. Right? Or a networking device. What if instead we threw a proxy into a container and just kind of treated it as a router? What about a distributed scheduler like Docker Swarm or Kubernetes or Nomad? Those things, they aren't machines that we go to the store and buy. Like when you go to installation of Kubernetes tutorial, in the official documentation, it starts telling you to get a machine and everything. But then you start running commands to install software, like the kubelet, like the Kubernetes API server, like the container networking interface. You're running all of these daemons. They're just processes. And it makes you wonder, why do I need a virtual machine to run all of that stuff? Right? Or why would I need a bare metal server? And you go back to this question, like you're the kid sitting at the desk with all of this red tape kind of preventing your creativity and your experimentation abilities. And maybe you can use a container for that. I did a thing, guys. It's a pretty fun repository. This is running Swarm in containers. And so, normally with Docker for Mac or Docker for Windows, you have a virtual machine, and it's got the Linux kernel in it, and it exposes these really nice interfaces to you to run containers first class. But it's just a single machine. Do you know you can run Docker in Docker? Docker is, again, just a set of daemons that expose APIs. And the kernel namespacing features are mature enough to where you can nest them. And so this is actually an abstraction that works really well. If you clone the repository and go into this special Swarm directory, there's a bunch of applications in here that you're able to play around with. But there is this Docker Compose YAML file. And instead of an application, we're just running Docker nodes. I have a really hacky shell script in here that spins up the Docker daemon and then waits for a swarm to come up. But you can join this to the host machine, and each one of these Docker and Docker services can scale out. And so there's this worker, and there's a separate class of worker called GCP worker. What this allows you to do is you can spin up a full application that actually represents a multi-node swarm cluster on your laptop with containers. And so there's no virtual machines beyond the virtual machine that's necessary to run my Linux kernel. In fact, if you run this on a Linux machine, you can have no virtual machines at all. You can just use containers to isolate processes into the namespace and use those processes to represent and affect a cluster that results in a multi-node distributed scheduler. And since each one of those nodes has a Docker in Docker daemon on it, you're able to schedule containers out in this kind of containerized infrastructure. You have literally multiple namespaces now where you can imagine or label different data centers and create separate network things that isolate from each other. And it's pretty neat. I'll show you guys. All right. One second. So I already have a single node in my cluster. Right? That's just my laptop. And I'm going to go ahead and deploy some tools really quick just to demonstrate a little bit about what's happening. There we go. Is that one? There we go. I think it'll be there. So listing the services in this administration stack, hopefully this pulls quickly enough. There's this visualizer service that's going to display all of the nodes. And, I'm actually kind of puzzled as to if this is maybe a networking thing. There we were. Seems like that's flapping for some reason. I don't know why. We'll just ignore that. All right. Instead of using the visualizer, I'll just show you with the node list. So we have a single node, and we go into this. Let's source some environment variables really quick. And then we just do, so let's add a worker to our cluster. It spins up a Docker and Docker container. Now on my single machine, there's this one DND container. It's running a shell script right now to join the cluster. So now we have two nodes. And just using Docker Compose again, we can scale the worker tier to like 4. And now we have like a bigger cluster. I'm still puzzled why that stack didn't deploy properly. But, similarly, there's some really terrific work by Mirantis. If I just open up this website really quick. To run Kubernetes in Docker and Docker. So if you kind of read through the README, it says, oh, you know, there's all of this stuff that you can do. But basically, the gist of it is that if you list in here, there's some scripts that you run. I think it's, yeah, you just run this DND cluster sh. And it spins up one for you. You can see here in this Docker PS, or the container list, that I already have some of these. They're not running at the moment. They're exited. So I'll just go ahead and start those. We'll do kube node 1. We'll start the second Kubernetes node. And then I think there is, of course, a master. And then if I just go ahead and exec myself into the master with a shell, then I should be able to, I'll alias k to kubectl here. So if I just say k get all, then I should have a cluster that's like running a bunch of services. Keep in mind that those processes, they weren't alive a moment ago. And I had just dead containers that I'd already killed. And you know, if you turn your laptop off, obviously your Kubernetes cluster isn't running. Start it back up, and you know, if you don't have your containers always set to restart, then you know, it's not there. But the minute that I want a Kubernetes cluster, I just start the containers that I had before. And they're going to resume the state. I start with the nodes, the workers, so that way the kubelets don't freak out that they're missing their API server. And then the master comes up afterwards, so that it doesn't like schedule pods everywhere when the nodes don't exist. And so that keeps me in a really stable place to reserve my state. A really nice feature, you know, about using these kinds of containerized clusters is that now you're not restricted in your development environments to a single node. It's not just this like shim that kind of reflects what production is really like. And you might not even have a production environment at that point. You know, if you might have like this kind of 3-month initiative, right, to eventually deploy Kubernetes into a test environment. And you don't have the time for that. By the time your 3-month initiative is gone by and you actually have a cluster to play with in your data center or in your cloud account, you know, you might have already forgotten what you were trying to experiment with. And so you're able to kind of use some of these tools available. Like obviously, Mirantis put in the work to containerize a Kubernetes cluster because it is an effective way for them to develop on the core parts of Kubernetes. This is a very empowering tool set. You know, and I don't want to you know, get too far into the ivory tower. We're talking about experimentation, right? And again, kind of bringing back to where we started. You know, typically we use a single, maybe 2 Vagrant machines to kind of help our developers use something that's consistent or maybe looks a little bit like production. And in the same way, what I've learned in my workflow is to, like, when I need something, just create an environment that gets me the information that I need, the isolation that I need, the binaries that I need, in order to play with an idea in a way that's like quickly reproducible and easy to throw away. But yeah, I did another thing. I was kind of having a conversation with Carl, the product owner of Puppet Discovery. And I was chatting with Scotty Colton at the Contributor Summit, you know, where we kind of demoed some of the old work of running Puppet in Docker. And I was like, gosh, they've done like this really great job. If you actually go to the Puppet Discovery technical preview, they have a single installation script that is runnable on Mac or Linux. And in that installation script, I kind of hacked it open. commented a bunch of stuff out that I didn't want. We actually use Minikube for some of the stuff at work. But the gist of it is that on a Mac, the installation, or yeah, on Linux as well, this installation script uses the VirtualBox driver with Minikube in order to get a Kubernetes cluster running on your local machine so that it can install Puppet Discovery. It's a very complex installation, actually. It has an operator that creates all of your other replica sets and services. It has a cron job that it uses from the Kubernetes 1.8 API to auto-update Puppet Discovery. There's some very cool things in there. Again, I already use Minikube for stuff, and I don't want that in my Minikube environment. It's kind of complex. I'm still in discovery mode with Puppet Discovery, trying to figure out how some of the pieces are put together. But I decided that I was going to try and figure out how to rip out that part of the environment and get just the section of this installation script that's necessary to run Puppet Discovery in my own Kubernetes cluster. And so instead of going out into GKE again or having an environment where I need to pay to use a multi-node kube cluster, I can just use exactly what I spun up right now. Right? This is if I do a k get nodes, right? I have a 3-node Kubernetes cluster running Kubernetes 1.7 here. And that's what we run in production. So it's a pretty small service layer. But I wonder, is Puppet Discovery something that I can deploy at Beatport? And after kind of commenting out some of this Minikube stuff, I was able to run it. This is just like some old bash history and stuff. But you can see that the installation script runs after I kind of soft forked it. And it starts up all of these things and waits for the resources before exiting. And if we look in my Kubernetes cluster, there's all of these different resources now. A lot of them belong to like a Jenkins deployment that I was using. And are any of these pods running? Let's find out. Yeah, there's some stuff running in here. I'm curious about this UI pod. I wonder if maybe we could get to that. And so I have this service right here, UI2, that's running a node port to the UI pod on port 3096. There is a limitation on Docker for Mac. This is not true on Docker for Windows. But unfortunately, I'm not able to actually ping the bridge network of the Docker daemon, which I think is pretty stupid. It's a security or like design feature of Docker for Mac, but it's not true in Linux and in Windows. I think that we should fix it, honestly. But one way that I get around that is, so basically the problem is now my Kubernetes nodes, they have IP addresses, but I can't actually route to them. They only have IP addresses within the internal network. The way that Docker for Mac wants you to do everything is to use the localhost splicing features of HyperKit. You can get around this by just not using Docker for Mac, honestly. But I have these functions. If I do like which expose, just in like my bash RC, that run a SOCAT container on a network at a target port. So basically, it's a container that runs SOCAT, and it takes connections and just throws them to a different IP address. And with this way, I can dynamically kind of expose a port. Yeah, hopefully that's big enough. I can kind of expose a port that wasn't intended to be exposed from a container. And if I, is that the right port? Let's see, 30968. 30968, we'll copy that. I'm going to expose that on this Kubernetes node IP that's just running on my local machine in a container on that port. Runs the SOCAT container, should be live now. And then let's throw that in there. And there we go. There's the Puppet Discovery UI. I can go in here and like kind of use the whole experience and add my AWS account and stuff like that. I haven't really dug into this. I got this working like an hour ago. But again, this is just my workflow, right? This is not like some kind of immaculate demo or anything that I put together. This is how I play with things. I use containers instead of really slow VMs, and I found that it's really changed my life because it gives me superpowers in what I spend most of my time doing, honestly, which is operating and experimenting with technology in order to help deliver value to my developers and the people that I care about using products that actually do something cool. You guys don't know, Beatport sells music to DJs. But, yeah, I have a couple other slides that we can kind of run through. Most of these are from an Ignite talk that I was privileged to be able to share with people back in March. You know, you can kind of see how some of this problem solving gets you closer to really quickly being able to mirror something as complex as your production or your test or lab environments on a single machine with very low overhead. You know, containers, unless you resource limit them, they all have the same view of the host. And what that means as well is that as you start to get into this kind of environment parity, you can like automate integration and failure tests and things like that. When something goes wrong in your production environment, maybe you would be able to recreate that state on your laptop, right? And in not something, you know, I mean, it's really sometimes not even feasible to use virtual machines for that because you just need too many nodes to kind of represent a network failure or like, you know, your load balancer not working or something like that. It's kind of cool ideas. Another kind of fun hack that I think would be neat for somebody to try is, I never got to this, but using Bolt to actually mutate the containers in an attempt to model the changes on the infrastructure and in the networks for these kinds of success and failure cases. I think that Bolts would be a really flexible kind of test runner for that. So if you were at the Contributor Summit playing with that or were curious about Bolt at the launch, that might be a fun thing to hack on. And ultimately, again, kind of bringing back to why. So we have all of these people telling us to start using these platforms. And what does that get us beyond what we already do using Puppet, right? I mean, like we do it at Beatport. We have this big mono repo that has all of our nodes in our legacy data center. They're all classified, running their own software and that kind of thing. And you know, beyond resource utilization maybe, so this whole bin pack algorithm with these distributed schedulers, scheduling process containers out across homogeneous infrastructure, treating your data center as one computer, maybe there's not so much value add. There's a lot of statistics, you know, research that's obviously heavily incentivized by Docker as a company to sell containers. But resource utilization, as you start to move towards a container world in the next couple of years, has the potential to really bring the costs of your CapEx down. Obviously, the runtime of a container has a very nice separation from the infrastructure needed to actually run the application and the way that the application is defined to run. And so what we see with these platforms is that we're getting away from coupling our code to infrastructure, or at least implementations of deploying that code out on infrastructure. And we're getting closer to creating application definitions that are declaratively dependent on the kinds of compute that we have. So you might have compute in a specific zone of a cloud, right? If you're using Azure, I learned that you can deploy into Africa. You might be kind of hesitant to deploy a PCI compliant workload into the public cloud, so maybe you might separate those things out. You might be concerned about latency, and so maybe you've labeled your nodes that way, right? Maybe you've labeled your nodes to be in a low latency portion of your cluster for doing batch operations on stock market data, you know? Or maybe you're trying to run build jobs. You want those containers to land probably on something that's nice and cheap, but still fast, like one of these ephemeral nodes from AWS or Google Cloud. these kinds of dependencies, this kind of information, that's what we want to couple our code to. It's not the infrastructure itself. And that's what kind of playing with these platforms and starting to move into containers for our experimentation and our iteration and the new things that we do, that's why we want to move into these places. These are the benefits that a platform buys us. And ultimately, kind of in that promised land, the same kind of things that Puppet gives us, but to a new level, maybe by a factor of 10, we're increasing the dependability of our iteration cycle. We are testing in a software declarative way, and we're shipping confidently. And that's a good place to be. So play with this stuff. It's really fun. Yeah. That's my Twitter. That's my GitHub. You can find my code there. But yeah, we've got some time. And so I would really like to be able to get a feeling of where you guys at. There has been a lot of talk about deploying Kubernetes, deploying into Kubernetes, using containers in different funky ways, running Puppet inside of containers, all kinds of strange things. And I would really appreciate any kinds of feedback about what people are learning and what they want to experiment on. It's a fun world out there, and there's lots of ways to take things. And, I would like to hear from you guys, like what questions you have and what you want to experiment with in the future. Yeah. Does anyone have questions? No? Cool. Well, I mean, I'm done. Oh, yeah. Yeah, what's up? What's your name? Darren. Darren? Derek. Cool. I'm missing a little bit of your question. Could you speak a little louder? I don't know if we have a mic or. For people who've used VMs a lot. I would say that you should just install Docker. And then there's a lot of hands-on labs. There's also a cool website, actually. I can show this to you guys. If you've never seen playwithdocker.com before, this is pretty neat way to get into a playground. This actually drops you into a Docker and Docker container out in AWS. All you need to do, you can actually even do this on your phone. It doesn't work very well, though. It's better at a keyboard. So you just hit this create instance button over here. And now I have a Docker daemon that I can play with. This is happening out in AWS. It's playwithdocker.com. My friends made this. And you can even make like a multi-node cluster in here, right? Just in your web browser. So, and because it's out on AWS, like you have like a really fast internet connection. And then you can start typing in your Docker run commands. You can make a swarm. You can do playwithkubernetes.com as well. And that'll get you into a Kubernetes cluster if you would like to play with some of those ideas. There is labs.playwithdocker.com. There's also a ton of great tutorials out there. Alex Ellis has a terrific blog. And maybe get into some Slack channels. Is that helpful? Cool. Yeah. We can chat more later if you want. But, anyone else? No? Cool. Well, I'm available all around and stuff, and yeah. Otherwise, I hope you guys have had an awesome PuppetConf, and let's go keep supporting each other, getting out into the community, sharing our hacks, and playing with new stuff so that we can make our lives easier. Thanks, guys. Appreciate it.